Hello and welcome to our project presentation. Today we are presenting our project work titled Expression Aware Intelligent Learning System for Enhanced Student Engagement. Before we begin, I would like to introduce our team. Myself, Ashwin M.A. and Hariharan S. and Lakshminarayanan. We would also like to extend our sincere gratitude to our internal guide, Ms. M. Shanbagadevi ma'am, for her continuous support and direction throughout this project. Today we will walk you through the core problem we are solving, the architecture of our platform, which we call EduQuest, a deep dive into how the code is structured, and finally a live demonstration of the system in action. Let's start with the problem. Current web-based learning platforms operates on a one-size-fits-all model. They deliver content but fail to monitor learner engagement in real time. In a physical classroom, a teacher can see if a student is confused and pass to explain. Online, these affective states like confusion, frustration, or boredom are practically invisible. Because of this, instructional support is usually delayed until after a student fails an assessment, which is often too late. To solve this, we developed EduQuest. EduQuest is an adaptive educational platform that transforms passive video learning into a responsive experience using real-time facial emotion detection. We built this on a three-tier architecture utilizing React for the front-end, Node.js and Express for the back-end, and Python and Flask for our AI service. If the system detects that a student is confused or frustrated, it automatically intervenes, parsing the content to offer contextual help, hints, or simplified explanations. We also heavily researched the literature on this, specifically around media pipe and convolution neural networks. To ensure real world accuracy, however, building this represented significant challenges, primarily around privacy. I want to emphasize our privacy first architecture. The webcam operates strictly on an opt in basis. More importantly, the system never stores raw video feeds. We only extract engagement scores and timestamps, which are processed locally and securely stored in our SQLite database. As you can see in our architecture, the React frontend handles the video player and captures the webcam stream. This is sent to our on-device engagement sensing module, which extracts facial landmarks. These signals are combined into an engagement score, which our Node.js backend uses to trigger adaptation rules like if confused, provide hint. Finally, this data populates an admin dashboard for instructors. Now, let's look at how this is actually implemented in the code. As mentioned, the project is divided into dedicated microservices. If we look at our Node.js backend in Server.js, you will see a standard Express application. We enforce rate limiting and handle secure user authentication via JWTs. From here, we mount modular APIs like API missions for lessons and API engagement for receiving the real-time engagement signals from the frontend. We deliberately choose SQLite for our data layer because of its lightweight nature, using Squalize to manage our user and engagement log schemas. The heavy lifting happens in our Python Flask service located in AI service app.py. Doing deep learning in the browser can crash a student's machine, so we offload it. The front end sends a base 64 encoded frame to our analyst endpoint. Here we use MediaPipe for highly efficient face detection and DeepFace for emotion classification. We don't just take the raw emotion, we apply a precision smoothing algorithm. This is critical because it prevents the UI from flickering widely if a student scratches their face or looks away for just 1 second. Finally, everything converges in our React frontend, specifically inside classroom.jsx. This is the core of the learner experience. This component dynamically renders the lesson video alongside a hybrid webcam capture component. As the Python service returns normalized data like focused or confused, this React component updates the focus bar state. If the attention drops below a certain threshold, classroom.jsx dynamically triggers the intervention pop-ups to re-engage the user. Let's see it in action. I'm going to spin up our multi-runtime environment. We have our React White server starting, our Express backend on port 5000 and our Flask AI service on port 5001. So here it is. It is the login page of our website. Here we can log in as a student, or if you are a teacher you can log in as a teacher, and this is for the admin. Then if you are new to this page you can sign in using this point, and that's it. Let's go into the dashboard by using the student login. Here we are on the learner dashboard. You can see our gamification elements tracking XP, total learning hours and available courses. Let's continue our journey in the introduction to Python module. This is the classroom interface. Notice that the system asks for webcam consent first. Once I accept, the AI assistant panel on the right becomes active. As the video plays, the system is silently analyzing my expression in the background. Right now, it registers me as a neutral or focused or confused. Notice what happens when my engagement drops or I display confusion. The Flash service detects the affective state change, smooths the data and alerts the front end. The video passes automatically, and the system prompts me with an intervention asking if I need a hint, a simplified explanation, or if I want to replay the last segment. This mimics a real tutor noticing a struggling student. Finally, let's look at this from the teacher's perspective. If we navigate to the instructor dashboard, teachers get a real-time class overview. Instead of just seeing that a student failed a quiz, the instructor can drill down into a student's timeline. They can see exactly where engagement dropped, allowing them to provide targeted support rather than guessing what went wrong. Here is just a glimpse and the tour of the dashboard for teachers' perspective. In conclusion, Edicus successfully bridges the gap between static content delivery and dynamic human-like tutoring by securely leveraging real-time facial expression recognition. We have created an environment that not only monitors but actively responds to a learner's needs. This completes our presentation and demonstration. Thank you for your time and attention. We are now open to any questions.